Today we're going to demonstrate modeling and fabrication of tube frame designs using computer-controlled cuts and bends to produce parts that fit together so that they're ready for welding. We will be using ARMA's ADS CAD/CAM software, which is available at the website. You can scroll to the bottom. There's a link for ARMA Design Studio CAD/CAM software. And scroll down to the download link. There's a link for Windows and for Java, which will run on Mac, Windows, and Linux. We will be running the demonstrations on version 1.2.41. We'll be using ADS to design chassis projects. You can also import mesh model objects from other CAD applications and convert them to tube structures in ADS. We will be using a CNC plasma tube notchers, and our CNC Tube Bender can use any manual bender. ARMA will be selling a CNC Tube notcher from armaautomotive.com. You can also use tube notchers from other vendors. There are PDF documents for notching, but they are for verification purposes to verify the positioning of tubing. They're not meant for manually cutting tube notching. The efficiency of a CNC tube notcher is so high that it doesn't make sense to build any project without a CNC tube notcher. Even a medium-sized project would be faster first to build your own tube notcher, and then it would be to cut and fit tubes by hand with an angle grinder or with a hole saw. The detail and accuracy needed for tube fitment, especially with tabs and slots on complex coping joints, is just not viable by hand. It would take weeks or months to build a medium-sized project, a tube-based project, whereas it would just take an hour to cut all of the tubes using a CNC tube notcher. So we'll be using the software, ADS, and two pieces of hardware to build these projects, the CNC tube notcher and the CNC tube bender. The software and hardware is designed to design using steel or aluminum tube, pipe, and tubing, cut and bend each part so that they can be fit together with interlocking joints, tabs, and slots, and so that they're ready for welding. Some framing jigs may be required to hold pieces together. Projects that you can build with this software and hardware include vehicle chassis, bumpers, roof racks, metal racks, and other tube frame applications. Designing and importing designs in ADS is free. A license for exporting cut and bend machine code, control code is available for purchase from armaautomotive.com. The ADS application has a view in the center, tools on the left, object list on the right, a selection menu, and then object properties. Tubes are built with this arc tube tool. First, click on the tool to activate it, and then click on the screen locations where you want the bend points for a tube. Double click to complete a tube structure. Click on the move tool, option, and drag to rotate. Tubes are defined by the centerline profile. They have points for each of the segment elements. With the object selected, you can choose material and an item from the list, and the item will include the tube diameter, wall thickness, a bend radius, which will be set by the CNC bender, and you can give it a name. So this is just an example. What we're going to do is add another tube that intersects. I'm going to click on a location, 2 points. I'm going to choose thickness. I'm going to double click to edit. I'm going to click OK. So now that I have two tubes, as an example, I'm going to notch this tube so that it intersects with this other tube. We select it by clicking on it. We can also choose it from the item list, and under the tools menu, tube notching, select notch angled tube intersections. it will generate the notch profiles. I'm going to hide the other and just select one. Now you can see, because the angle of the intersection is at an angle, it uses the outer circumference on the acute side and the inner circumference on the obtuse side. So this angle is larger than 90 degrees. It'll use the inner diameter. This angle is less than 90 degrees, so it's going to use the outer diameter. The reason for this is when this tube cut profile is being cut and the CNC tube notcher, our notcher cuts perpendicular, so the torch is always 90 degrees, and when this is cut, we will need the part to fit. So if I'm looking from the front, this tube will be cut so the point connects here, and this tube will connect right here. The two tubes will touch right here, and the two tubes will touch right here. So we'll just look at the other notch profile. You can see it also does the same thing. We'll look at some of the other tools. I want to cut the ends off of this tube, so I'm going to select Tools, Tube Notching, Add Notch Tube Ends Outer, and then it will add these two notch features. This will cut these parts from this material. So these parts both have bends, and I want to add bend markers so that the notcher will add marks where the bend needs to be positioned. So I'm going to click on this one, Tools, Tube Notching, Add Bend Markers. So it's going to add these markers right here. I'm going to add it to this tube. Add bend markers. So we're going to get here, 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 and here. So this will be scored in the metal during the cutting process, and it will allow us to position this tube in the bender so that we know exactly where to start. And we can also verify that once we bend the material, that we can verify that the bend starts and stops at the markered positions. So now I also want to add a new feature to these bends. I want a tab in a slot so that I can ensure that this tube is positioned with this tube in the exact spot that we want, and that it's not welded in the wrong location. So I'm going to, with this notch selected, I'm going to click Edit, or I can double click. I'm going to select pieces in this joint right here. I want some more points, so I'm going to subdivide. I'm going to select these three. I'm going to view from the front. I'm going to pull these up because I want this to enter into the tube. So this is going to act as a tab. So I'm going to select these pieces, and then I'm going to select this tab and notch feature. I'm going to view from the front, and then I'm going to click up just to have it generate. Select the move tool again. Now I'm going to click OK, and in this tube there is now a slot feature. So the slot feature needs to be modified so that it actually fits the correct length. So I'm just going to edit this feature. I'm going to view from the front. This length is good. I'm going to select the inside, view from the front, and I'm just going to move this in. It's a little too far, so that it comes into the inner diameter. So now when this material is cut, this pin will fit through the hole in this tube. Now, when I cut these two pieces, I'll hide this one by clicking on the hide children, and I can see this tube will be cut with this profile, and it'll have this pin, and then when this tube is cut, it will have this hole for the slot. Now we have our example combination of tubes with bends, cuts, coping joint, and tab and slot. Now we want to fabricate it. So I'm going to click on CAM for computer aided manufacturing. I'm going to go down to the export arc tube notch G-code. I'm going to click on this, and these settings are specific to the CNC tube notcher. So each machine is going to be different. 360-degree width in inches. The units are specified in your scene. This defines the amount the motor needs to move to rotate the chuck that holds the tube 360 degrees. Each machine is going to be different. The feed rate and fast feed rate specify in the G-code the instructions that tell the machine how to cut and bend these parts, how fast to move. So each plasma notcher, each plasma torch is going to have a different setting based on the material, and the fast rate is between cuts. So the feed rate is during cuts. Enable and disable are for the machine controller. In this case, we're using Mach 3 and Mach 4. So M4 and M5 will enable and disable the plasma torch. Continuous mode specifies that each of the features of the tube are cut from start to completion. So when it unrolls the tube, it's going to cut a feature from the start and then unroll the tube until it's done. So this may roll the tube more than 360 degrees. Stock length, CNC capacity length, and fixture scrap length are for nesting. So when ordering tube, it usually comes in 20 to 24 foot lengths. Our machine has a capacity of 12 feet, and each time you fixture a tube into a machine, there's a length that the torch can't access, so this will become scrap. And then this will generate one G-code with file with all of the pieces in it. With the nested orientation, it will tell you which tubes to cut in certain length, and then it'll optimize which parts to cut to minimize the amount of scrap waste. So I'm going to click OK. And that will generate the G-code for the notching. And now we want the G-code for the bending. So I'm going to click CAM, arc tube bend G-code. This feature requires manufacturing to or unlocked. So I'm going to click CAM, arc tube bend. And these properties are specific to the CNC Tube Bender. The minimum start length and minimum end length define the amount of material that must extend forward from a bend and back from a bend, so that the back end can be grabbed with the chuck and the front end, the die, can grab the material. Invert the chuck and invert the length basically allow us to configure quickly reversing directions for our particular machine. Minimize chuck rotation enabled will move the chuck left or right to minimize the amount of rotation. This is very important when bending long pieces of metal because the die bends horizontally on the Y axis. If a piece of material is being bent and a lot of material is sticking off the end, it may not physically be able to rotate such that the tube would pass through the ground. So this option will allow you to bend a long bent piece of tube and have the tube bend up into the air. You will have to check the clearances in your space. I'm going to click OK. And if we don't have a CNC tube bender and we want to do the bending manually, we can use these bend PDF. So I'm going to click on these two options and generate the PDFs. And then we'll take a look at the code. Once you've generated the G-code and PDF files for your project, you can load the files quickly by clicking on the CAM menu, load export folder, and it will bring up the file folder with all of the generated documents. In this case, we're looking at the tube notches, so I'm going to click on the tube notch folder, and you'll notice two folders, one for the parts with G-code files for each, and PDF for the instructions. We're going to use NC Viewer to look at the G-code. So I'm going to open it in a web browser and drag the files across and look at the file. So this is the edge profile. Here are the markers and the end. Here's the other file. You can see the ends, the slot, two bend markers, and then the end. Another feature that you can use when building projects to estimate manufacturing cost is this fabrication button, which will print out a summary of estimated costs based on the materials and assembly. There's an invoice that you can click to load, which will include the materials, which includes notching, bending, welding, and this is just an estimate for now. We can manufacture these projects, or if you're building projects, you can also estimate what you can charge your customers when you're building. This also includes documents for the notching, the materials, the lengths, the bending, and the specifications. So you can pass this along to customers and verify that the project is what they expect. And the PDF for the notching is for reference, so it will tell us information about the file, the date, the length of material, the diameter, wall thickness, bend radius, compensated, and it will show an example of the features that are cut and where the markers are. This isn't intended to be enough information to cut the tube by hand, because the difficulty in cutting this by hand is such that it would be easier to build a CNC tube notcher or to buy one than it would be to attempt to cut these by hand. This tube notching PDFs are really for reference, and they're good for communicating with clients to verify that everything is in the order is correct. Tube nesting will consolidate all of the parts into one file. So tube nesting is for manufacturing. The notches and the individual files is good for prototyping, so that you can manufacture one part at a time. And the nesting G-code will combine all of the files. Tube bends is going to generate PDF and parts. So this G-code is for our CNC Tube Bender. Here is the content of the file. It has information about the part, the material, the lengths, and then instructions for the length, chuck rotation, and then the bend angle. So our CNC Tube Bender will take this file and bend a tube. Okay, so the tube bends also generates the PDF. Now, these can be used if you don't have a CNC Tube Bender. Bending manually will just require careful consideration, because each of the bends will have a natural spring back depending on the type of material and a few other elements. So you'll want to be careful to bend. You will need some compensation above this angle to get the result of this, but it can be done. The CNC Tube Bender will bend this to the correct specification. We typically get accuracy of 0.1 degree bend, sometimes 0.2 degrees. So the file has information about the PDF has the information about the file name, the part, the date, the material, diameter, wall thickness, bend radius. Each tube, when it's bent in a CNC Tube Bender has a die for a particular type of material, and the die has a bend radius. But you'll notice this 4.5 degree bend radius, and you'll notice this comp for compensated 4.65 inches. When bending tube, the material will naturally spring back. So if you bend to 90 degrees, the material will spring back. So you won't get 90 degrees from a single 90 degree bend. It will spring back to 85 or something. The same also applies to the bend radius. When bending a tube, the bend radius when the tube is fully tightened in the die is 45, but as soon as you release the material, the bend angle is going to spring back, and the bend radius will also expand. So our CNC Tube Bender will compensate for the bend angle. It will bend, measure the resulting angle, and then do another bend that will compensate to result in this angle. So these coordinates on this file are compensated so that where the bends start and stop is compensated so that this geometry of your CAD file is using the compensated bend radius, so that when your parts come out of the notcher and bender, that they will fit exactly in the dimensions that you have in your CAD file. So even though your CAD file will have this bend section with a bend radius of 4.5 degrees, the actual bend radius that these files are generated for is the compensated bend radius. This results in the tubes. You can cut them and bend them and then fit them together. You can have tubes. We have tubes with lengths of 6+ feet with 4 and 6 bends in them, and then the two pieces fit together and the tabs hold each other perfectly together. One of the other settings that you may want to change is tube bend radial growth. This is a scale factor, and each material has the bend radius will grow based on the physical properties of the metal. You can adjust the settings here if your machine doesn't match with what you're getting. I'm just going to load some projects that we are using the tube frame for. This is our Jeep Gladiator front bumper. It has 3 tubes and then plate. So a center hoop with 2 bends, a lower and an upper section with 4 and 6 bends, and they are fitting together with these tabs and slots. There are end caps. And these parts can be cut in about 10 or 15 minutes and bent in also about 10 minutes or so, and then fit together on a jig that hold them in place. And the slots hold the ends, and this hoop in the lower bar, and we have plates, and then I can tack them together and weld. This is another project. This is a chassis design project for our vehicle. It's a work in progress. The blue arc tubes and the light blue alternate are mirror reflected, duplicated components. So we only have to design one side, and then the mirror plane will be replicated. We use this mirror plane tool to implement those. In the project file, we can have overlay the body, engine components, glass, wheels, interior, mechanical, and we can see how everything interacts. If you're interested in the equipment that we use to cut and bend our tubing projects, we have some products under our website tools menu. We have a CNC Tube Notcher kit. This product is currently being revised. We're going to be building this from the ground up, so a new machine will be available soon. If you're interested, you can reach out and get some details on that product. Additionally, we also have a CNC Tube Bender kit that will fit onto the Bailey RDB 250, which turns it into a 3-axis CNC machine for automation. So this bender with the table and our kit, along with a computer, is compatible with our ADS software for modeling designs, importing designs, and then generating the G-code that both works for notching and bending simultaneously. The idea is that you make your designs and cut them, and once the parts are cut, you bring them right over to the bender. The tubes have markers for positioning, and then you run the code, the bending code, and it takes parts from start to finish, and then you can fit them together with coped joints with complex tabs and slots, and they will fit together. You'll need minimal jigging for framing everything together, and you can just weld your projects. If you have any questions about the software or products, feel free to reach out. This is all a work in progress as well. Features are being improved, and we will be adding updates regularly. This is an experimental feature for defining tube structures with numerical input. This tool is experimental. It's a work in progress. It's not fully implemented. If this is something that you would like to use and you would want support for this, then reach out and we can add more support to this. So the tool, ArcTube tool, takes input from the user's mouse, clicking on the display, and it can be edited with points. And one of the areas where this struggles is defining dimensions between points or angles, because it's a free form user input by clicking or dragging on the tool. In this case, I'm going to select a 1-inch diameter just so that it has thickness. If I edit the tube, I can select the points and I can manipulate it. I can add more, remove, modify the points in that way. But if I want to define the structure with numerical input, because I have that data, then there is this tool object under the object menu, numeric tube editor, and it will load the fields on the bottom. So tubes are defined in multiple segments, which are straight segments connected by some kind of joint. And the joint is going to be a bend with a rotation around the axis of the segment, and then a bend angle, which is deformation from a straight line. In this case, I'm going to add another segment as an example, 4 units. I'm going to set the rotation to 90 degrees and then bend angle to 45 and add this segment. I'm going to add another one. Let's go 4 inches as well, 90, 45, and add it. So we can construct this form. The form will list each of the segments. So the segment 1 is this straight segment here. Segment 2 is right here, and then segment 3 is right here. So we can add, edit, and remove. Currently, editing the segments in the middle of the list is not fully implemented. So the lengths segments A, B, and C are these segments split into 3 groups. So the A is the beginning, and it represents the curved length because the start has no connecting segment. There's no length. B is this straight segment here, and then C is the end. So right now you can just see what the straight length is, and the full length is the distance between the points that define the segments. So this segment 2, the length right here is A, this straight segment is B, and this remaining segment is C. And then in the third segment, this will be A, this will be B, and this will be C. So this tool will let you either reconstruct tube structures from a PDF or from some other form of input and generate a structure that way.